In this video, we are going to compile a C++ library for iOS to be used in Xcode. I've written down the instructions in this repository called iOS framework-cmake, and I've also written down a script that we will use later to convert the built libraries into a framework. Now you can clone this repository on the local storage. Now let's get started. First of all, we need to install Homebrew. So let's copy this command, paste it into your terminal. It requires sudo access, so write your password and press enter. So once Homebrew is installed, we can go back to the instructions in the README file and now install CMake using Homebrew. I've actually installed it previously. Now let's copy this part of the code, which is going to create a folder called nlopt iOS, and we'll change that directory into this newly created folder. For this video, we are going to use nlopt as an example, which is a nonlinear optimization library. But in order to compile it, we also need to get a file from another repository called iOS-cmake. So that's also why we are going to clone that repository. And the file that we need is that you can see in the next piece of code called ios.toolchain.cmake. So now we are already in the new folder that we created. So let's copy the code to build this library for the device, which means that the architecture will be ARM64. Let's wait for this to complete first, and then we're going to build it for the simulator as well. So I'm currently using an Intel Mac, so that's why I need to compile it for the Intel Mac architecture as well. Let's speed it up a little bit. Now the build is succeeded and the installation is done for the device. Now let's repeat it for the simulator. So we copy the other part of the code and paste it into a terminal until this is also finished. Now let's have a quick look into the install device folder to see if we have the libraries which are built and also the include files present in this folder. And apparently it looks like that we do have all the required files. Now the next thing we need to do is to convert these files into a framework, and for this we are going to use the script that you can find in the repository attached in this video description. Now we can open this file and let's make a copy of it so we can make changes into the file specific for this nlopt library. You can rename it to suit the library that you are working with. In this case, it is nlopt. So let's copy the location of this folder nlopt_iOS that we created in the beginning and where the library is installed, and replace these variables in this shell script. So we have to change out directory, dvirlib device, dvirlib simulator, as well as headers directory. Then we'll have to find the code sign identity, which I will explain in a moment. So yeah, we can use this command to find the signature, and this is with an assumption that you have already installed Xcode and you have already set your identity in Xcode. So also I just made a change in the info.plist file, so you can write the bundle identifier as you want. And also I've written down my code sign identity here, which I have blurred for this video. And just the last thing, in the headers dir, we also need to point to either the install device or install simulator header files locations. Now, since we have already done it, so let's go to this folder, and first we will change the permissions. Please see that in the readme file, and then we run this file, and now we know that the framework creation is complete. We can go to the framework folder in the nlopt.framework folder, and we see that all the required things are already present there. So it's time to use this framework into an app in Xcode. So let's create an app called nlopt-xcode. Now the first thing we want to do is to bring the framework into this project, and we can use drag and drop. For example, we can click and drag this into the project location. In this case, so make sure that we have checked add to targets. In this case, it seems like that the framework has been copied into preview content folder, but we want to take it out and paste it into the root folder of this project. Now we need to go to the project settings in build settings to modify the location of the framework, because in the beginning it was copied to preview content. We'll have to see and modify it. So yeah, in the framework search paths, we see that the path was previously going into preview content folder. Since we have now moved it into the project directory, so let's delete that entry and add this one. Now, in order to use this framework, we will have to create a new file or a bridging header. So let's create a bridging header called nlopt-xcode-bridging header, and also enable the project net targets. Now let's copy and paste different code into it, because we're working with C++ library. And now we also need to give the path to this header into the Objective-C bridging header path. So we need to give the full path of this file into this section. And now please see that the file that we just created is inside another folder called nlopt-xcode in the project of the same name. So that's why we gave the full path here. Now we do see some errors. For example, it can't find nlopt.h file, and which also means that we did import the framework, but we did not give the path to the headers of the framework. So here we're going to give the path of the header files of this framework, which is actually inside the framework, the way we have built it. So this is the path of the framework, and within the framework there is a folder called headers, and this is exactly where this nlopt.h file is present. Now, after setting the headers folder, we will clean the build folder, and you can use the shortcut command Shift K for that, and then build again using command B. So let's do that. And now we see that the build is succeeded. Let's move to the content view and paste a new code which we have written. So it's a minimal code to execute nlopt version function, but we see some errors. It says cannot, nlopt Xcode crashed because nlopt.framework is missing. So we perhaps need to go to the general section and enable the embed and sign option in the frameworks, and I think they should just work now. So we build again, build is succeeded. We can run the code in simulator, wait until it boots up, and here you go. So let's try and pressing the button run test, and yeah, indeed we see the print output of the version of the library, which is 2.10.0. Now we are creating a C++ file here because sometimes we do want to work in C++ and not directly in the content view, for example. So let's give any name nlopt version check.cpp and make sure that the targets is the target project is checked. Now it also created a header file of itself, but let's first work a little bit on the C++ file. So in this case, the idea is that we will check the version here, and we want to print the output on the terminal in this function. So in order to print, we need to import this IOStream, which is a standard C++ library. Let's import that, and also since we are working with nlopt, so let's import nlopt.h header file as well. And here we are going to, of course, write the definition of the function, which will get the version of this library. We return void because we just want to print the version value, print nlopt version, and also we don't want to pass anything. So let's declare some variables: integer, major, minor, and bug fix. Let's call the function nlopt_version and pass the addresses of these variables. We need to go back to correct it. Yes, bug fix. We'll use stdcout now to print the version that we will get. I forgot to add a semicolon in the second line, so let's go and put a semicolon in the end. Yes, that is it for this CPP file. Now let's go to the header file. We want to make some changes here, and also want to add the declaration of this folder. So I will paste the code here. replacing these two lines. Yeah, and the declaration is already here now. Now we need to make sure that this new header file is also included in these paths. Now, since this is inside the folder called nlopt-xcode in the project directory, so we just need to give that path. That is it. Now let's try and build the project, see if everything is okay. So we cleaned the build folder first, and now we are building it. The build is succeeded. So we can go back to the content view and change the code here. Instead of calling this function directly here, we are going to call the function that we just created in another CPP file. But in this case here, we're going to write a Swift function to call that CPP C++ function. Let's call it check nlopt version, and yeah, here we're going to call the C++ function. And let me copy and paste it here. And of course we need to make the change here. Let's also change the text and the button text. And then nlopt version check. Run check nlopt version. So it says that it cannot find print nlopt version in scope. Let's go back to the bridging header and also include the new header file that we just created. Include nlopt version check.hpp. Yeah. Let's try and build this project again. Build is succeeded. We can now try and run it in the simulator. Oh, and it's running. Oh, this is perfectly fine. We click the button and then we get the print statement out. So that is it. CPP file and header file in the Swift code, in the Swift project, with the header file, importing the framework, how to compile it. Yeah, and that's it. Thank you. Good luck with your projects.